We're going to talk about different types of network attacks here. Now I'm going to start with kind of a classic, and it's called a Smurf attack. And a Smurf attack is actually where we ping a broadcast address, and I have to specify to ping here with the -b that I mean to ping a broadcast address. Otherwise, it's going to generate an error. And one of the reasons for that is what I'm about to talk to you about is these Smurf attacks. So I can ping the broadcast address on my network here, and you can see that it's getting a lot of duplication. So all of these responses that say dupe, those are duplicate messages because I've issued an ICMP echo request and I've received multiple replies to that ICMP echo request. So why would I do this? Well, I might do this because I want to attack a system, and the way I would do that is by spoofing the source address. So I could pretend to come from 1.2.3.4, for example, and since ICMP doesn't actually do any verification of source or destination, it's easy to spoof that source address, and all of the replies will go to that spoofed source address. So if I were to generate an ICMP echo request to a network broadcast address that had a lot of hosts on it that replied, then I could generate a lot of replies that went back to a particular host. And a lot of years ago, when this was popular, say back in the 1990s, there weren't places where you could get really big bandwidth really cheap, certainly not like today, and so lots of people had not a lot of bandwidth. So if you could generate requests that used up a lot of bandwidth, then you could knock somebody offline. So this was kind of a big deal for a while, and we eventually figured out that we could protect against that, and one way of protecting against it was this amplifier registry here that you see. And there's a list of the current top 10 Smurf amplifiers, and you'll notice that the networks are all sort of small in size. Although the top one generates 520 dupes out of a network that only has 254 hosts on it, potentially, since it's a /24. And you'll also notice the registration date. Many of these go back to 1999, and that was probably about the point where this registry was created, if I were to guess. So that's one way we did it, was to create this registry, and you could check this registry and just block messages coming into your network that were ICMP that were originating from this particular network block. The other thing we did was we figured out that we could shut off something called ICMP directed broadcast, or what we call ICMP directed broadcast. And that directed broadcast is what I just did there, where I said, here's a broadcast address, go ping it, and we're going to get a lot of replies. So I am in proc here on a Linux system, and you can see there's an ICMP echo ignore broadcasts. Echo ignore broadcasts. So that's set to 1, which means this system is set to ignore broadcast messages, or ICMP messages that are directed to a broadcast address. So we're not actually going to reply to those sorts of messages. Now, one place that this sort of attack was used, and used with a fair degree of effectiveness, was in a system called Stackeldraht. Now, Stackeldraht was actually something that came out of work by a guy by the name of Mixter, he created this thing called the Tribe Flood Network, or TFN, and then updated it with TFN2K, and eventually there was something called Trinu, and Trinu turned into this thing called Stacheldraht. Now, Stacheldraht, the word is actually German for barbed wire. Stacheldraht used these sorts of attacks that were popular back in early 2000, which is when it was used, and one of them was Smurf attacks. So what Stacheldraht did was created the very first distributed denial of service attack against companies like Yahoo and eBay. And I can remember at the time was working at a large internet service provider, and all of the big tier 1 internet service providers were on a big conference call trying to figure out how to block all of these things. It was really unknown at the time and really unexpected. Nobody knew how to deal with it, particularly since they were all spoofed. So the thing about it here is that what Stacheldraht was a client-server sort of model, or client-master model, and you can see here's the source code for the client, and up above we've got the mserv and the setup, which did all of the configuration. So you would connect to the master server and issue commands to all of the clients or the zombies that were in this DDoS network, what we now call a botnet. And you would issue commands to them, and so you would have a lot of different hosts going through your attacks for you, or generating your attacks for you. And what ended up happening was you had the ability to create a lot of bandwidth where you wouldn't normally have that ability. Say you've got 100 hosts, you've got 100 times the amount of bandwidth that you yourself would have available to you to generate these attacks. So you might have these 100 hosts generate Smurf attacks, fake Smurf attacks, with a spoofed source IP address, and so you'd have a lot of messages coming back. Or you might just generate a SYN flood, which was another popular one. We had a lot of SYN floods. And a SYN flood is where you just do a lot of half-open connections until the point where the server no longer can deal with the requests that are coming in. So Smurf attacks were really popular a while ago. They are less popular now, but they kind of begat this distributed denial of service attack. I mean, it's sort of the same idea where eventually what you're just doing is overwhelming the amount of bandwidth that the target has available, and you're flooding that target so that it can't respond to legitimate requests. Same thing with a SYN flood, although it's not a bandwidth attack, it's a resource attack, where the server just eventually gets to the point where it can't handle any more connection requests. So that's just a handful of the types of network-based attacks that you may run into.